Imagine everything you've ever known. Now, imagine it's just a tiny speck in a vast, ever-expanding cosmos. This is our universe, a place of incredible size, mystery, and beauty. It's a place where stars are born, galaxies collide, and the very fabric of reality is stretched across unimaginable distances. Our journey begins at the very beginning, with the event that birthed it all, the Big Bang. Hi, welcome to the Space Diary. Today we'll travel through time, witnessing the universe's incredible transformation. From the first moments of creation to the formation of the first stars and galaxies, we'll explore the key events that shaped the cosmos into what we see today. Fasten your seatbelts as we embark on an exhilarating journey through billions of years, exploring the grand narrative of our universe. Get ready to be amazed. The Big Bang. The name itself evokes images of a colossal explosion, a cosmic firecracker lighting up the void. But the Big Bang wasn't an explosion in the traditional sense. It was something far grander and more profound. Picture, if you will, not an empty void, but a point of unimaginable density and temperature. This point, containing the seeds of everything that is, suddenly began to expand. This wasn't matter exploding into space, because space itself was born in that instant. The Big Bang was the expansion of space itself, an inflation so rapid and so profound that it set the universe on a trajectory it follows to this very day. From this singularity, our universe was born, and with it, the very fabric of space and time. In the blink of an eye, an incomprehensibly short fraction of a second, the universe underwent a period of unimaginable expansion. This wasn't just about space expanding, but about the very laws of physics being written as the universe cooled. Energy, confined within that singularity, began to transform. And this wasn't the energy we experience every day, but a primordial soup of fundamental particles. As the universe continued to expand and cool, this energy began to condense into matter. Remember Einstein's famous equation, E=mc²? This elegantly describes how energy and matter are two sides of the same coin. In the early universe, this equation played out on a cosmic scale. From this maelstrom, the building blocks of everything we see around us, quarks, leptons, and bosons, began to emerge. In the newborn universe, it wasn't just particles that were forming, but the very forces that govern their interactions. In the cauldron of the Big Bang, the fundamental forces of nature began to separate and take distinct forms. Gravity, the force that would one day draw matter together to form stars and galaxies, emerged. Electromagnetism, the force responsible for light and the interactions between charged particles, came into being. Then there were the strong and weak nuclear forces, governing the interactions within atomic nuclei. These forces, though less familiar in our everyday experience, are essential for the very existence of atoms and the elements that make up our universe. These forces, once unified in the unimaginable heat of the Big Bang, began to separate and exert their unique influences. It is through these fundamental forces that the universe began to organize itself. The early universe was a hot, dense soup of particles constantly colliding and interacting. As the universe expanded and cooled, a crucial transition occurred. The fundamental particles, once too energetic to bind together, began to form composite particles. Protons and neutrons, the building blocks of atomic nuclei, formed from quarks. Electrons, much lighter particles, zipped through this cosmic soup. This era, known as nucleosynthesis, saw the formation of the lightest elements. Hydrogen, the simplest and most abundant element, formed in vast quantities. Helium, with its 2 protons and 2 neutrons, also emerged. This primordial soup of hydrogen and helium, forged in the crucible of the early universe, would become the raw material for the first stars. The universe, like a hot ember removed from a fire, continued to cool as it expanded. This expansion wasn't just about things moving apart from each other, but about space itself stretching. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots don't move across its surface, but they do get farther apart because the balloon itself is expanding. The universe was doing something similar, only on an incomprehensibly larger scale. As it cooled, the energy of the particles within it decreased, and the universe transformed from a seething cauldron of energy into a vast, cooling expanse. This expansion and cooling set the stage for the next chapter in the universe's evolution, a period known as the Cosmic Dark Ages. The universe, once a brilliant inferno of light and energy, entered a period of darkness. This transition marked the end of the universe's fiery birth and the beginning of a long, cold epoch. This wasn't the darkness we experience at night, but a darkness far more complete. It was an era devoid of stars, planets, and any form of visible light. The universe was filled with a fog of neutral hydrogen, a gas that absorbed any light that was present. This thick fog acted like a cosmic veil, shrouding the universe in obscurity. This period, lasting hundreds of millions of years, is aptly named the Cosmic Dark Ages. During this time, the universe was a cold, dark expanse, waiting for the first light to break through. But hidden within this darkness, a faint echo of the Big Bang persisted. This echo was the only remnant of the universe's fiery beginning, a whisper of the past. This echo, stretched by the expansion of the universe, is what we detect today as the cosmic microwave background radiation. It is a faint glow that permeates the entire universe. This faint afterglow, discovered in the 1960s, provides a snapshot of the universe as it was just 380,000 years after the Big Bang. It is a window into the universe's infancy. It's a treasure trove of information, allowing us to study the early universe and its evolution. By analyzing this radiation, scientists can unravel the mysteries of how the universe transformed from a dark, featureless expanse into the rich, complex cosmos we see today. In the vast emptiness of the early universe, a profound transformation was about to unfold. In the depths of the Cosmic Dark Ages, gravity was at work, silently orchestrating the next phase of cosmic evolution. Slight variations in the density of matter, present since the Big Bang, began to grow, setting the stage for the birth of the first stars. These denser regions, pockets of slightly higher gravity, began to draw in the surrounding hydrogen gas, slowly but surely. Over millions of years, these pockets of gas grew denser and denser, their gravity becoming stronger and stronger, pulling in more and more material. Finally, the pressure and temperature at the cores of these collapsing gas clouds became so intense that something incredible happened. The conditions were ripe for a cosmic miracle. Nuclear fusion, the process that powers our sun, began. Hydrogen atoms fused to form helium, releasing immense energy. The first stars, massive and short-lived, burst into existence, ending the Cosmic Dark Ages. Their light pierced through the darkness, illuminating the universe. These stars, known as population 3 stars, were unlike any stars we see today. They were the universe's first beacons of light. Composed almost entirely of hydrogen and helium, they burned bright and hot, flooding the universe with ultraviolet radiation, a new dawn in cosmic history. This radiation began to ionize the surrounding neutral hydrogen, a process known as reionization, transforming the universe into a more complex and dynamic place. The first stars, though short-lived, had a profound impact on the universe. These primordial giants, burning brightly for a brief moment in cosmic time, set the stage for everything that followed. Their intense radiation reionized the surrounding hydrogen, making the universe transparent to light once more. This pivotal event, known as the Epoch of Reionization, allowed light to travel freely across the cosmos, illuminating the vast expanse. More importantly, these stars created the first heavy elements. Through the process of nuclear fusion, they forged the building blocks of matter. Within the nuclear furnaces of these stars, hydrogen and helium were fused into heavier elements like carbon, nitrogen, and oxygen and iron. These elements are essential for the formation of planets and life as we know it. These elements, the very building blocks of planets and life itself, were scattered into the cosmos when these stars exploded as supernovae. The explosive force of a supernova spread these elements far and wide, seeding the universe with the ingredients for future stars and planets. Gravity continued to sculpt the universe, drawing together gas and stars to form the first galaxies. These early galaxies were the cradles of star formation, where new stars were born from the remnants of their predecessors. These galaxies, vast collections of stars, gas, and dust, clustered together, drawn by their mutual gravitational attraction. Over time, these clusters grew larger and more complex, forming the intricate cosmic web that spans the universe. And so, from a tiny, incredibly dense point, the universe expanded, cooled, and evolved, giving rise to the magnificent structures we see today. stars, planets, galaxies, and the vast cosmic web that connects them all. This grand tapestry of the cosmos is a testament to the power of gravity and the relentless march of time. The universe is still expanding, still evolving, and we, as curious inhabitants of this grand cosmos, continue to explore its mysteries. Each discovery brings us closer to understanding our place in the universe and the forces that shaped it. The journey that began with the Big Bang is far from over, and the universe holds countless wonders waiting to be discovered. As we look to the stars, we are reminded of the incredible journey that has brought us here and the endless possibilities that lie ahead. In the next part, we'll explore how these stars paved the way for solar systems, planets, and eventually life as we know it. Stay tuned as we continue our journey through the history of the universe.